So now that we have those, I first put them on a number line to see which way they're going, and then from there I do my interval notation. So I have 0 and 2. So here you have x is less than or equal to 0, so it's a closed circle on 0 and less than. And x is greater than or equal to 2, so you have a closed circle on 2 and everything greater. So, from this we can conclude that the interval notation, we want negative infinity to 0, bracket, since it's closed circle, union, bracket 2, since it's a closed circle, to infinity, parentheses. So this, what's in the box in white, is your final answer in interval notation.
So the first problem reads, the eighth, solve the inequality and graph the solution on a real number line. So the first thing you have to do is set the top and the bottom both equal to 0 so that you can find your key numbers. So you would solve this, and our key numbers are plus and minus 1 and 0. So now we would write out our test intervals. So negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. So now for each test interval you need to set a test value to use. So for the first one, negative 2, negative 1/2, 1/2, and 2, and this is to test if this interval is a solution to the inequality. So then you would plug each test value into the original equation. So negative 2 squared minus 1 over negative 2, 4 minus 1 over negative 2, negative 3/2, and since that's a number that's less than 0, this interval would work. So that is a solution. So the next one would be negative 1/2. Which gives us 1/4 minus 4/4, or 1, over negative 1/2. Negative 3/4 over negative 1/2. The same thing as multiplying by negative 2 over 1, which gets us 6 over 4, or 3/2. That's a positive number, so it does not work, so it's not a solution. So the next test value is 1/2. So 1/2 squared minus 1 over 1/2. 1/4 minus 4/4 over 1/2. Negative 3/4 over 1/2 times 2 over 1. Negative 6/4, or negative 3/2, which is a number less than 1. So that is a solution. So that means that interval is a solution. And the last value is 2, so 2 squared minus 1 over 2, 4 minus 1 over 2. That's 3/2, but that's a positive number, so it's not going to work. So now that we have our solution intervals, we can rewrite them and then graph them on a number line. So it was negative infinity to negative 1, and 0 to 1. So on a number line, that would be everything less than but not equal to negative 1, and everything not equal to 0 and not equal to 1, but in between them. It's like this. Okay, so in the next problem, we're going to do the same thing. So solve the inequality and graph the solution on a real number line. So first you have to bring everything over to one side. And then you want to combine them, so you're going to multiply the 5 by x plus 2, and then the negative 3 by x plus 6, and then put it all under the same denominator. So x plus 6, or x minus 6, and x plus 2. So then distribute and combine like terms. And now we can set the top and the bottom equal to 0. In order to find our key numbers. So the first key number is negative 14, 6, and then negative 2. So now we would write these out on an interval for our test intervals. So we would have negative infinity to negative 14, negative 14 to negative 2, negative 2 to 6, and then 6 to infinity. So now we'd find a test number in each of these intervals. So for the first one, you could use negative 15, then negative 3, then 1, and then 7. So now we'd plug in each of these test values into the original equation. So we can use this one. So 2 times negative 15 plus 28 over negative 15 minus 6 times negative 15 plus 2. Which equals negative 30 plus 28 over negative 21 times negative 13. Negative 2 over 273. And because this is a negative number, we know that this interval doesn't work. So the next test number is negative 3. So we would do 2 times negative 3 plus 28 over negative 3 minus 6 times negative 3 plus 2. So it's negative 6 plus 28 over negative 9 times negative 1, which gives us 22 over 9, which is a positive number. So we know this interval does work. The next value would be 1. So we would get 2 plus 28 over negative 5 times 3, which is 30 over negative 15, which simplifies to negative 2, but that's still a negative number, so this interval would not work. And then 7, so we'd plug in 7 for x. Which would give us 14 plus 28 over 1 times 9. So that would be 42 over 9, which is a positive number. So this interval does work. We can rewrite the intervals that did work. So -14 to -2 and 6 to infinity, and then draw these out on the number line. Okay, so not inclusive, but everything in between -14 and -2, then non-inclusive of 6, and everything bigger than 6. So the last problem would be to find the domain of x in the expression. So the expression is the square root of x squared minus 4. The first thing we would do is set what's underneath the square root greater than or equal to 0. And then factor this out to x plus 2 and x minus 2, which gives us our key numbers of -2 and +2. So now we would write out our test intervals. So -infinity to -2, union -2 to 2, union 2 to infinity. And then write a test number for each of the intervals. So for the first one, -3, then 1, and then +3. So now we want to plug these back into this equation. So -3 plus 2 times -3 minus 2, which is equal to -1 times -5, or 5, and since that's greater than or equal to 0, that one does work. So the next one would be 1, so 1 plus 2 times 1 minus 2, that's 3 times -1, which is -3, which doesn't work, so no. And then finally 3, so 3 plus 2 times 3 minus 2 is 5 times 1, which is 5, which does work. So this interval does work. So in this case, the domain would be from -infinity to -2 inclusive, and 2 to infinity inclusive.